Hi, and welcome to the Microphotonics Imaging Laboratory here in Allentown, Pennsylvania. Each month, we'll be bringing you new instructional videos, providing you tips and tricks to use with your SkyScan instrumentation. Let's go ahead and jump into the tip for this month.
This month, we're looking at some artifacts that can arise from a phenomena in micro CT imaging known as the partial volume effect. So basically, the partial volume effect arises from the fact that we are projecting fixed objects onto a pixel array. Now, the edges of these objects, such as this bone drill core here, never really line up exactly with the edges of the pixels. So each pixel readout gets a contribution from either air or bone or marrow space, and that affects the intensity that we see. So when we go to try and segment data sets, in this case this is bone inside of a drill bit, which I've already cropped down to the area I want to take a look at. So if we go to our segmentation window within CT analysis, you can see that I've kind of already played around with my settings, kind of dialed in what I'm looking for. I think I'm going to go with about 70 to 150 because I do a pretty good job of capturing the bone that I'm interested in quantifying. Now you'll see we have some noise which we'll need to clean up, but the strange artifact you'll see is this ring that surrounds our whole data set. So where is this coming from? Well, that's an example of the partial volume effect in play. Basically, these pixels near the edge of the image are showing up bright enough to be segmented as bone, even though it's just air and marrow space there. And this is arising from the intensity of the absorption of the metal drill on the outside here. So let's go ahead and move to custom processing. We'll talk about how to get rid of these artifacts. Now, in the interest of keeping this video short, I've already created the task list which I want to carry out in order to get rid of the artificial signal we're getting from this drill bit. So the first step of any analysis in CT analysis pretty much is to threshold the data. So we'll go ahead and run our task list and we can apply the threshold we selected. Again, looks like what we saw before. So now we'll go ahead and do a black pixel despeckle to get rid of some of these small noise pixels that are showing up as black. You can see a lot of the little black pixels are left. We still have some pores, but these are probably pores within the bone, so we want to keep those. Now we can go ahead and do a white despeckle, the same magnitude, and we'll see that that got rid of a lot of our white noise, but unfortunately we still are left with this halo around the outside that's coming from that drill bit. So the way we're going to get rid of that is actually going to be by using a morphological opening function. In this case, we're going to apply it in 2D. We're using a round kernel, and we're applying it to the image, and a radius of 3 pixels. So you can see that when we click this, we will resume our task list, we'll run our operation, and now we see that we've pretty successfully removed that ring. So how do we do that? Well, the morphological open function basically first shrinks all pixels by the specified distance, in this case 3. So the edge of every sample, or every selected piece here, was shrunk by 3 pixels. Now anything smaller than 3 pixels was essentially erased. Then, after shrinking 3 pixels, it expands or dilates back out to fill out the full size. So in this way we preserve the edges of the bone, but we get rid of the ring. Now, we still have a couple little pieces that weren't really fully taken care of, so we can run a much larger despeckle here to get rid of these last little spicks of noise. And now we're left with a pretty good representation of the bone. So if we cycle back and forth using our Alt-1 and Alt-5, we can see the bone we were trying to select here and what we end up with in our analysis. Now it looks like we could improve some of these thinner features a little bit, but overall it's a pretty good example for how to get rid of artifacts arising from partial volume effect. If you have any questions, please reach out to us at Microphotonics and we'd be happy to help you with your work. Have a great day.
Hello. Thank you for watching this installment of our video tip of the month. At Microphotonics, we strongly believe that the research you do changes the world and we're happy to support you in your efforts through these videos, through our advanced training courses, and our annual workshops. Through these efforts, we strive to make sure that you are getting the most from your Bruker Micro CT machine. If you have any questions on this video or any other questions, feel free to give us a call or send us an email. Thank you again, and have a good day.